Hey everybody, this is Christian, and in today's video we're talking about how to create a well-structured HomeLab network. Because I know this is unfortunately a topic that's often overlooked, because IT and tech nerds, we sometimes just love to tinker and put different bits and pieces together to make it just somehow work. But trust me guys, a well-organized network is not only much more secure, it's also helping you in your HomeLab journey, because it makes things much easier when you're later expanding it. However, I know that when you're starting out, it is not easy to build a sophisticated network architecture from the ground up. You have to learn many different things and terminologies like network zones, segmentation, subnetting, VLANs, IP, DHCP. So I thought it might be useful to create a general guidance video with some practical examples showing you how I'm organizing and structurizing my HomeLab network. And I think this will be super helpful for beginners if you're just starting out, but also if you already have an existing HomeLab network infrastructure, you will always find areas to optimize and improve. And before we jump right into structuring our HomeLab network, let me also talk about how to securely access your HomeLab network from outside and show you my absolute favorite tool when it comes to remote access called TwinGate, the sponsor of today's video. Because TwinGate is always my first choice when I need to log into my HomeLab servers over SSH or access my other administrative tools, because it is a secure, fast and damn simple solution. It is what we call ZTNA in tech, a zero-trust network access platform, where every network request has to be verified and authorized, otherwise TwinGate won't let the request go through. And this technology even works through NAT devices and firewalls without any port forwarding or firewall exception. So you can just securely log into your device no matter where you are or where you are connecting from. So I strongly recommend you to try it out. Please check out my video tutorials if you want to learn more about TwinGate and how to set it up on your HomeLab network, or how to integrate it into DevOps tools like Kubernetes or Terraform. It is super cool, and the best, it is completely free for up to 5 users and 10 different remote networks. So start making your HomeLab network not just more organized, also much more secure and accessible via TwinGate. Of course, I will drop you a link to their website in the description down below. Alright guys, so now let's jump into structuring our HomeLab network. The very first thing that I would always do is start outlining our network structure and topology. No matter if you already have an existing HomeLab, then just write down what you have. Or if you're planning to create a complete new infrastructure, then I think it's always best to start with a good plan. And it can vary from very simple topology. So I've seen many HomeLabs where people just have one switch and one home router and a 192.168.0.0 network, and that's totally fine. But I've also seen many other crazy people having sophisticated enterprise level structures, like they have different segments, they use VLANs, maybe even dynamic routing like BGP, OSPF, or even STP for redundancy. Of course, we won't go into that, so don't be worried, but there are many crazy dudes out there that do these things in HomeLab. So I just can say there's no real right or wrong how to do things in HomeLab, yeah? Especially if you're just starting out and VLANs are a bit too much for you, then just start simple, right? I've gone through that process a couple of times because I'm also always changing my infrastructure. What is super important when you're outlining a network, that you have to write it down somewhere. And I can just recommend my absolute favorite tool, Excalibur, where I do all my diagrams and graphics for the YouTube videos. This is such a fantastic tool. It even has a free tier that you can use on your browser. And you can store these diagrams on your local device, so you even don't have to use a cloud subscription or anything. It's absolutely fantastic. And here you can see how I've organized and structured my HomeLab network. You can see a lot of different elements that I've used to structure and organize things. Some controlling devices like my firewall system that has multiple IP addresses, my switch, and then my servers, my private devices. Here you can see I also write down the IP addresses of my most critical devices like my Proxmox cluster, the Kubernetes cluster, the main production servers, my NAS, and the Home Assistant server that I'm using. I'm not writing down IP addresses for my entire home network. So here on the left side, you can see the LAN area where I've documented some devices like my Sophos access points, my Xbox, the TV, my Mac Studio, the MacBook, iPhone, and these type of things here. But I'm not writing down IP addresses for these devices, as they mostly get dynamic IP addresses from my DHCP server. So you can take this as an example how to structure a HomeLab network, but I really want you to build your own topology. All right, so now let's dive a bit deeper into some of these technologies that you see here. So first of all, I want to start with segmentation, because this is a crucial thing. And the names that you have seen here above these areas, these are called network zones. So a network zone is just a logical group of network interfaces or devices. And I think this is also for a small home lab a pretty important technology, because you can use it to better control what devices or what users have access to your critical infrastructure, to your servers. You can apply specific firewall rules or access controls. And honestly, it's also much better for organization, because I can directly see where my home lab servers are, and I cannot confuse them with other devices in my private network and so on. So here above you can see the WAN zone. This stands for Wide Area Network, and I use this to define anything that is beyond my firewall, so my home router and also the public internet. Here you can see I'm using a network starting with 192.168.8.1.0 with a 24 subnet mask. I will later explain in a bit more detail what that means. Then we have my LAN zone. This is for my private network, again, where I have my TV, Xbox, or the other just regular home devices that you might have. This has the network 10.10.00/16. My prod network, this is my actual production home lab, so to speak, where all of my servers and other stuff that you see in the videos is located. It starts with 10.20.00/16, and then I'm also thinking about adding some devices in the future to a DMZ, which stands for Demilitarized Zone, and this provides a separate layer of security by isolating the public accessible servers from the internal network. So when I would host my private website from a server in my home lab, I would usually not put this into the same production home lab network where all the other testing devices are. I would put all the devices where people can access this from outside my protected network into a separate network zone, so I can much better control what is going in and out of that zone and enforce stricter security policies when something is coming from the internet to my servers, instead of when I'm just experimenting and trying out something. But yeah, I haven't actually used this. I will at least make one or two adjustments to this structure to be able to effectively do this, but yeah, that's a topic we'll talk in a few minutes about it. So these are the network zones that I've created. And by the way, if you're confused by these IP addresses, most people will be familiar with the 192.168.whatever/24. This is what many home routers use by default. And then the other networks like 10.10.00, 10.20.00/16 are also IP networks in the private IP range, but they look a bit different and they have a different subnet mask, this /16. So what does that actually mean? Well, I don't want to make a complicated video about subnetting, but just to show you how that generally works is the /24 is the CIDR notation of the 255.255.255.0 subnet mask. So that means that the first 24 bits of the IP address are used for the network portion. Only the last 8 bits are used for the host addresses. IP addresses assigned to devices in that network can vary from 192.168.0.1 to 254. And when you take a look at these networks that I have created, let's also do the IP calculation for 10.20/16, for example. Here you can see that means the first 16 bits are the network portion and all the rest is available for host addresses. So a device that has the IP address 10.20.53.145 is in the same network as the 10.20.0.12, for example. my servers usually start with 10.20.0, and my Kubernetes cluster, for example, starts with 10.20.20. So then I can immediately see, oh, this IP address is part of my Kubernetes cluster, and I can better assign dynamic IP addresses in that Kubernetes cluster's IP range for any load balancers or something like this. So when I see an IP address in my HomeLab, I can directly recognize where this is coming from and what's the purpose of this device. But yeah, that's maybe just my crazy habit. You might just want to keep it simple and stick to the 192.168, whatever, 24 subnet mask. You get so many host addresses. I think that's more than enough for a small home network. So don't let yourself be confused by this. But I personally just find it a bit easier. Now, let's also come back to the main question, why the heck did I do this? Again, as I said, it is really practical to enforce security policies, because if you're creating different network zones in your HomeLab network, a device from one zone cannot necessarily access another zone. And the way how I control this is with my firewall. I just recently switched my main firewall to OpenSense. You might have seen that video. If you didn't, then go and check that out. But just to show you how I'm doing this here, you can see my firewall has IP addresses in all these networks. So it's the main controlling device and the main gateway where traffic coming from one zone going to another zone has to pass through. And of course, this main controlling device, the firewall, can then say what device or what user has access to what service or device in another zone. So here, for example, you can see when I go to my firewall rules, I have created some rules for the LAN zone. Here you can see my Mac Studio is currently in the LAN zone having this IP address, and it's allowed to go anywhere. So any zone, any port, any destination, because I'm the administrator of my network and I have full access to everything. But of course, I don't want my regular private devices like my TVs, my iPhones and whatever to have access to any server. Just to a few services that I specifically define in the firewall rules. For example, here you can see my DNS server that is currently located on the server production 1 under the 10.20.02 IP address. By the way, the 32 CIDR notation means this IP address is really just that one host. So all the devices coming from the LAN network can access this IP address, but only on port 53. And the other firewall rule will provide access to all the LAN devices to this IP address on port 443, which is my home assistant server, so I can control the lights on or off. And then I created a rule to block anything else that is coming from my LAN zone and is trying to get access to the trunk network, the prod network, and the management network. As you can see here in the network topology, these refer to these elements. I've not created one for the DMZ because, as I said, it's a work in progress. But yeah, that's how I'm applying this. The next topic that we also need to talk about, and I know it's getting a little more complex, but the technology that allows me to do this and which is super practical is called VLANs, which stands for Virtual Local Area Network, because without VLANs, you would have to buy a separate physical switch for each network zone and connect it to a separate physical port on the firewall, because only then the different network zones are physically separated from each other, and the firewall is the only main gateway where traffic needs to pass through. But as you can imagine, buying separate physical switches for a HomeLab is absolutely insane. It is super costly. Not only that you need to buy the hardware devices, which cost a lot of money, it also costs in terms of power consumption, because each of the devices consumes power. And as you can imagine, this is a super important technology in professional IT networks. Everybody is using VLANs there because it allows you to virtually split your physical switch into multiple virtual switches, where you can define for each port on the switch which VLAN it is on, so that devices from one VLAN are really separated from devices in another VLAN. Let me show you on my sofa switch how exactly that works. So here I've created all these different VLANs. So every VLAN needs a unique identifier, which is also sometimes called the VLAN tag. Just imagine this VLAN ID stands for a separate physical device. You see it a little better on the sofa switch when you go to VLAN settings. So here you can see every port of the upper row of my network switch is assigned to my private network. And these ports here are assigned to my production HomeLab network, the same for DMZ. So you might have noticed that some of these ports have a different symbol. Most of them are untagged ports, so that means packets that are sent out to these ports and received from the devices are just treated as normal packets, but they are just routed in between all these ports and not sent out to other ports. And one port is assigned as a tag port. So the tag port is something like a transport port for sending out or receiving traffic from multiple VLANs. So you can see the same port 22 is assigned to the other VLANs as well. Whenever the switch is receiving a network packet that is coming from these untagged ports and has to be sent out to this tagged port, the switch will add a small 12-bit VLAN identifier to each of the network packets that are sent out to the tagged port, so the device on the other end will know from which VLAN this network packet is coming from. That, of course, requires a configuration on that device as well. So on the device, you also have to configure all these VLANs, and the VLAN IDs, of course, have to be matched. As you can imagine, this port 22, this is exactly the network port where my OpenSense firewall is connected to. Here you can see all these VLAN interfaces with the same VLAN tag as I have configured on the switch. And this way, I have connected my switch to the firewall, transporting all these different VLANs, and then the switch is segregating the traffic coming from the firewall out to the individual untagged ports. Now, this is really great to achieve a solid network security concept. I know it might be tough to understand VLANs because I know it from my own experience. A long time ago, I was working as an IT service technician where I needed to go outside to customers and setting up networks, setting up computers and stuff. And one customer bought 3 new HP switches with VLANs, and it was the task to refactor the existing network structure and set up VLANs for this customer because they wanted the same. They wanted control of separating the servers where the critical and important company data was stored on and the other employees' computers. I had no idea about VLANs, and it was a complete mess. It took me the whole day and some of my weekend to find out how to connect these devices and how the untagged and tagged ports work. And it was so frustrating, but I can tell you after that weekend, when I finally understood how this works and I could set up the company's network, I was so happy and I was so excited because I had learned something new and I just wanted to try it out at home and apply the same security concept. And yeah, that's also what I'm using right now for my HomeLab. The next step that I'm aiming to achieve is to add this DMZ for the public-facing services and add the Proxmox nodes to the VLAN concept as well. So that means what I'm trying to do is the ports where my Proxmox servers are currently connected as untagged ports to the prod network, I want to make these tagged ports to the DMZ as well, so that it would allow me to create a virtual machine on the Proxmox nodes and put this into a different VLAN. So, for example, I could have a server in the DMZ zone with an IP address 10.30.02, for example. And whenever this device has to send out traffic somewhere, it has to be routed through my firewall where I can define, hey, this DMZ server is not allowed to go into my production HomeLab network. Even though it is running on the exact same physical hardware, using VLANs, I can separate these two networks out. And I think this would also be a great tutorial to show you how to set up VLANs on Proxmox, but I need some more time researching this, but that's definitely what I have in mind for the future. So as you can see, every HomeLab network has some room for improvement. And before we wrap up, I also want to talk about another topic. Don't worry, it's not as complicated as VLANs, but it is also quite interesting. I hope you're still up for some more stuff. So let's also talk about IP ranges, because these help me to further split a single subnet into multiple logical sections. And this is super practical for DHCP to avoid running into some IP address conflict problems and so on. DHCP, by the way, stands for Dynamic Host Configuration Protocol, and this is the main network protocol used to automatically assign IP addresses and also other network configuration parameters to devices in a network. When you apply plug in a device like a laptop or a computer to your switch, it will send out a broadcast packet to locate a DHCP server, saying something like, hello, I need an IP address, and the DHCP server responds to the device and assigns a new IP address that is not used by any other device. And it tells it where the gateway is, where the DNS server is, and so on. How you can easily manage different IP ranges and DHCP. I'm also using OpenSense as my main DHCP server, because what would be better, right? So let's go into Services, DHCP, and let's go to the LAN interface. So here you can see I have enabled the DHCP server on the LAN interface, but I didn't assign the full network as an IP address range. I'm limiting this to 10.10.10.10, so I can easily remember this, to 10.10.10.199. So these are all IP addresses that are used by the DHCP server. And when I go to leases, you can probably see some of these addresses here. Yeah, so here's my iPhone, for example, the 10.10.10.10. The watch, okay, that's probably the Apple Watch or whatever, has this address, 17, 18, and it goes just on until 199, and then it's finished. And I usually create all my static IP addresses, so when I statically configure an IP address on a device in a completely different range. So this usually has 10.10.0 or 1 or 2. I could just use any other number than 10. Because if you would just have the DHCP range in the same range as you configure static IP addresses, you might run into a pretty common problem. That is, when a DHCP server tries to assign an IP address to a device that is already taken by a device that is statically configured. So the DHCP server doesn't know the IP address, and it will result in an IP address conflict. Now, of course, the DHCP server isn't really dumb, so it usually checks if an IP address is already taken by a statically configured device before it's giving this IP address to another device. So in reality, these problems don't always often occur, but it could be that you have a device with a static IP address that is offline for quite some time, and the DHCP server hasn't seen that in a while, so it assumes, oh, this IP address is free, and it assigns it. And once the statically configured device with the same IP comes online again, you run into this problem. So I had this into some professional networks back in the days when I was working as a service technician. So I definitely learned my lesson to configure the IP address range from DHCP in a different range where I configure static IP addresses. Also, another best practice tip I can share to you is when you have devices you want to configure with DHCP, but you want to make sure these devices always get the same IP address and not dynamically, you can configure them in the DHCP server under static mappings for this device. And here you can enter the MAC address, which is the worldwide unique identifier for this physical network interface. So no other device in the world will have the same address. And you configure this to have a static IP address that is ideally outside of the regular DHCP range. So here, for example, I can directly see any device that has an IP address 10.10.10. Anything beyond 200. This is coming from a DHCP server, but it is statically mapped to a specific device, as in this example, my Mac Studio, which always has this IP address. And this allows me to create firewall rules specifically for this Mac Studio, and no other device might accidentally receive the same IP address. All right, again, it doesn't have to be that complicated, so you could also think about if you're using a 192.168.0 to make the static range from 1 to 20, and then have a DHCP range starting at 21 to 199 or whatever. So there are many different configurations possible according to your infrastructure and your requirements. But yeah, that's basically how I organize and structure my HomeLab network, and I thought it might be a good example to show you how you can easily repeat some of these techniques and maybe improve your network infrastructure and organization to achieve a strong security concept and just have a better overview and can remember IP addresses better. I hope that really helped you. But yeah, that's it for today. If you want to learn more, please also check out my other videos about Excalidraw, my Bind9 DNS tutorial, and of course my OpenSense firewall tutorial. I will drop you those in the description box down below. And as always, thank you so much for watching. A big thanks goes out to all my supporters and YouTube members. You guys are really amazing. And I'm gonna catch you in the next one. Take care. Have a nice day. Bye bye.